is question 13 of civil engineering paper of GATE 2019 afternoon session. The velocity field in a flow system is given by V is equal to 2y plus x plus yj plus xyz k. The acceleration of the fluid at 1, 1, 2 is. So, in this question, the velocity field is given. We need to find the acceleration of the fluid at position x is equal to 1, y is equal to 1 and z equal to 2. So, this question is from the topic of fluid kinematics. You may study about the motion of the fluid particle by watching lecture 16, Lagrangian and Eulerian descriptions, fluid mechanics by Professor Subhashish Datta, IIT Guwahati. So, just let's recall about the velocity and acceleration field. So, in the Cartesian coordinates, the velocity of the fluid particle can be represented as a vector v is equal to uy plus vj plus wk, where u, v and w are the velocity component in x, y and z direction respectively, and the acceleration of the fluid particle at any position is the time derivative of the particle's velocity. So, after simplifying this equation, we get the acceleration A is equal to del b by del t plus u del b by del x plus v del b by del y plus w del b by del z. So, we can also write this acceleration equation separately for x direction, y direction and z direction. So, now in this question we have given the velocity vector and we need to find the acceleration field. So, first of all write the data which is given. So, the velocity v is given as 2y plus x plus yj plus x y z k. So, here it can be seen easily that u is given as 2, v is given as x plus y and this w is given as x y z. So, if we find del u by del x, so it will be 0 as u is independent of x, y, z. So, del u by del x equal to 0, del u by del y is equal to also 0, del u by del z is also 0. Now, del v by del x is equal to 1, del v by del y is equal to also 1. If we just derivative of this velocity with respect to y will give you the value 1. Again, del v by del z is equal to 0 as this v velocity in a y direction is independent of x, independent of z. So, del v by del z equal to 0. Now, del w by del x is equal to yz, del w by del y is equal to xz and del w by del z is equal to xy. Now, putting all this value in this equation, we will get this ax, ay, az. So, ax is equal to del u by del t. Since u is independent of time, so this term will be 0. So, 0 plus u. So, the value of u is given as 2 in question and del u by del x, just we have calculated del u by del x is 0. So, 2 into 0 plus v. So, v is x plus y, del u by del y is 0, we have calculated, and w, the value of w is x, y, z into del u by del z. So, del u by del z is 0. So this all this term will be 0. So the value of ax will come as 0. Now ay is equal to del v by del t. Again the velocity component in y direction, that is v, is equal to x plus y. So it is independent of z and time. So this term will be 0. Del v by del t will be 0 plus u into del v by del x. So u, value of u is 2 into del v by del x. So del v by del x we have calculated 1, 2 into 1 plus v. So v is x plus y, and del v by del y. So del v by del y is 1 plus w. So w is x y z into del v by del z. So del v by del z is 0. So it is 0. So after calculating this, after simplification, we will get 2 plus x plus y, x plus y. So if we write ay for position 1, 1, 2, then we can write this 2 plus x. So the value of x is 1 plus y. So the value of y is also given 1. So it will be 4. So ay at position 1, 1, 2 is 4. Now az equal to del w by del t. So again w is independent of time. So del w by del t will be 0 plus u into del w by del x. So the value of u is 2. Del w by del x is yz. So yz plus v. So the value of v is x plus y, and del w by del y. Del w by del y is xz. So it is xz plus w. So the value of w is xyz into del w by del z. So the value of del w by del z is xy. So it is xy. So it will be 0. So 2 yz plus x plus y xz plus x square y square z. Now az at 1, 1, 2 will be 2 into 1 into 2 plus this x plus y, that is 1 plus 1 into x is 1 and z is 2 plus x square. So the value of x square is 1 square, y square, that is 1 square again, z is 2. So if we solve this, it will be 2 plus 1 plus 1 2 into 2 4 plus this will be 2. Sorry, this 2 into 2, that is this will be 4. So 4 plus 2 is equal to 10. So it will be, so az at position 1, 1, 2 is 10. Now we need to if this a at x y z is equal to ax I plus ayz z plus az into k. So the value of ax, we got the value of ax is 0. So this is 0 plus ay. So the value of ay we got 4. This is 4j plus az, the value of az we got 10. So this is 10j. So we can, this will be a at position 1, 1, 2. So we can write the acceleration at position 1, 1, 2 is 4j plus 10k. So here in this question we need to select the right option. So the answer is 4j plus 10k. So option D is the correct option for this question. Thank you.